All right, welcome to this next video on some terminology of ratios. So just some understanding different kinds of ratios, for example. So we're going to look at this example here, this little image that just has a number of different shapes in it. Well, you just study that for a second and think about what is the total number of shapes in this image. It should have 10, hey? There's 10 items if you count them up. Total number of X's, 5. Total number of O's, 2. And the total number of triangles, 3. Okay, so when we're looking at a variety of different things, we'll notice that these three numbers are similar to each other because they just tell you the amount of a certain thing, the amount of a certain part of that picture. So we'll call these the parts. But 10 is unique because 10 shows the total, right? So 10 we call the whole. Right? So these are the parts and this is the whole. And so all kinds of ratios that we use, we're going to compare numbers. We're going to compare those numbers using multiplication or division, which is what ratios are. But there's different ways we can compare them. So we can compare them where we compare a part to some other part, or we can compare them where we compare a part to a whole. So we'll look at those two different types. Both use the same kind of ratio thinking, but they're somewhat unique. So consider, for example, the ratio of X's to O's in this example. So there should be, as I count it, 5 X's to 2 O's. So we get a ratio of 5 to 2. This is a part to part ratio. Triangles to circles, I see 3 to 2. 3 to 2. Consider this. What about the number of X's and triangles to O's? So if we add up the X's and the triangles, we have 5 and 3. That gives us 8 altogether. And the O's are 2. Notice that in this case we might say something like, if you total up the X's and the O's, you get 4 times as many X's and triangles as you do O's. So there's that ratio thinking there, that one's 4 times more than the other. Hi, Kat. How are you doing? We're learning about ratios right now. Say hi. Okay. So carrying on. For a bit. We are going to do part to whole ratios. So part to whole ratios, before we carry on. Part to part ratios are good for things like recipes. They're like scores in sports games, for example. They are comparisons between two numbers. They're a proportion between two different things. Whereas part to whole ratios, these are going to be a proportion of a whole. So they compare to the entire everything. That's what fractions are. This is what percents are. That sort of thing. So consider, for example, the X's. The X is 5 out of 10 of all shapes. Right? We could write this as 5 to 10. But I'm also writing it as 5 over 10. Right? We haven't read them. 5 over 10. 5 over 10 is half. Right? So that's half of all shapes are an X. If we look in here and we say, how many X's? Well, there's 5 of them and there's 10 total, so the X's are half. So this is a part to whole ratio. Circles, we could say that this is 2 to 10. because we have 2 of these for the 10 wholes. Right? This is the same as 2 tenths. 2 tenths, if you know your percents, you know that that's like 20%. So you could think, this is 20% of all shapes. You can see why this is like the same thing as percents and fractions, part to whole ratios. Okay. So you're going to practice working with ratios, and I will see you in the next video. Sorry, I'm distracted by my cat playing. Go in, enjoy practicing a little bit with ratios, and we'll see you next time.